Okay. Hello everybody. This is Richard from OneClass, and today we're going to be doing some popular math questions. Um, we're going to go over 9 problems for today's problem set, and if you have any more questions or need help with homework or any other tutoring services, please be sure to check out the links in the description below. So with that being said, let's get underway with our problem set. So the first problem that we're going to deal with here, there isn't any explicit problem up here, but I'm just going to follow through what was written down here and see if I can infer what the problem is. So we know it takes 42 minutes to load 3.5 trucks. So let's do 42 minutes for 3.5 trucks. Okay, so we want to find the time taken in loading of 6.5 trucks. So this is a classic proportion problem, and essentially what we're going to have here is we're going to have two ratios, and we're going to set them equal to one another, and one of these terms we don't know. So we know the 6.5 trucks, but we don't know x, and we don't know how many minutes it takes for 6.5 trucks. So because our proportions are set to minutes over trucks equals minutes over trucks, that means that our proportion is set up correctly, and what we can just do is cross multiply. So we're going to get 42 times 6.5 is equal to 3.5 times x. So if we carry out this multiplication, this is just so this is 261, I believe. Hopefully I got that right. So oh no, it's not actually. One second, let me just, okay, it's 273. I apologize. So 273 is equal to 3.5x, and then if we divide by 3.5 on both sides, we get the number of minutes. So dividing by 3.5 here, we see that x is equal to 78 minutes. And that would be our answer. So if we go through the work here, said nicely here, this person found out that it takes 12 minutes for a single truck, which is another way that you can go about this, but I feel like the proportion, you kind of just get the answer right away by solving it. So this person also got 78 minutes, so I'm going to say this is correct. Great job, and that is the end of problem number 1. Alright, so for question number 2, we have find an equation of the plane through the points 2, 1, 2, 3, minus 8, 6, and minus 2, minus 3, 1. So I'm going to write these points out. I'm going to label them P, Q, and R respectively just to be consistent with the work here. So we're going to have P is 2, 1, 2. Q is 3, minus 8, 6, and R is minus 2, minus 3, and 1. So to find the equation of the plane, we know that this plane is going to contain all 3 of these points. The other thing we know is that there is going to exist some sort of normal vector. So this vector is perpendicular to the plane that contains these 3 points. In order to find what that normal vector is, and we do need it for actually getting the equation of the plane, we're going to take 2 lines. So ideally, because both of these points lie on this plane, so assuming, let's say we have P, Q, and R, so assuming that these 3 points lie on this plane, we can define 2 vectors, 2 lines on this plane. And because they're both on this plane, then they're normal, so the line orthogonal to both of these lines should be the normal vector. So essentially what I'm saying is that to find our normal vector, we're going to have to do PQ cross PR. And before I jump too ahead of things, we have to first define PQ and PR. So PQ here, because we're going from P to Q, we want to take the point at Q and subtract it from the point at P. So we're going to have 3 minus 8 and 6 minus 2, 1, and 2. And then we just subtract each coordinate element-wise, and we get 1 minus 9 and 4. Okay. So with that, we can also define PR. So PR would be R, the point at R, minus the point at P. So we would get minus 2, minus 3, 1, and then minus 2, 1, 2. And dragging this down a little bit, we get that PR. Subtract element-wise again, we get minus 4, minus 4, minus 1. Okay? So with these two values found, we can now compute what the cross product is. So essentially, we are finding n is equal to the cross product of 1 minus 9 and 4 cross minus 4 minus 4 minus 1. And we're going to write this as a determinant. So the first, and this is just the definition of a cross product. So our top row is going to be the I hat, j hat, k hat, which are the unit vectors for the I, j, k, or x, y, z direction. And then we are going to write our vectors row-wise, so as so. And then we are going to find the determinant of this matrix. So first of all, consider the I hat term, and the way I do it is I ignore the column and the row, and then I take the determinant of this matrix. That's the way it's done, the smaller matrix. So we get 9 minus 16. And then because we are doing a 3 by 3 determinant, we have a subtraction here, so minus j hat times minus 1 minus 16. And then we get plus k hat, so ignoring this column and this row, I accidentally just drew a plus there, so ignoring this column and this row, we get minus 4 minus 36. And then we can write this out as 25 I hat minus 15 j hat minus 40 k hat. So this is our normal vector right here, and we could also write this the following way, where I, j, and k correspond to the x, y, and z direction. So now if we want to find the equation of our plane, we're going to take n hat and we're going to dot it with basically the vector that corresponds to um, x minus a comma y comma minus b comma z comma c, z minus c, I'm sorry, where a, b, and c are one of the points on the plane. Because we already know what the normal vector is, all of the points are gonna, the line you can draw with any of the points on the plane are gonna have this normal vector. So as long as we pick one arbitrary point, a, b, c, we can solve this, and also you have to set this equal to 0. So writing out n bar, the vector n as 25 comma minus 15 comma minus 40, we have to dot this with one of the points, and I'm going to choose the point 2, 1, 2. So I'm going to do x minus 2, y minus 1, and z minus 2. So that's the 2, 1, 2 point. It's on the plane. Now, by dotting it, we just take element-wise, we take the product and then the sum of all the element-wise products. So we get 25 times x minus 2 minus 15 times y minus 1 and minus 40 times z minus 2. So distributing out everything, we get 25x minus 50 minus 15y plus 15 minus 40z plus 80 is equal to 0. Finally, by combining like terms, so our only like terms here are constants. So we are going to get minus 50 combined with plus 15, so minus 35. Minus 35 and 80 gives us 45, so we're going to get 25x minus 15y minus 40z. So I'm sorry, that was minus 35, 45 is equal, or minus, I gotta fix this, minus 40, no, plus 45 is equal to 0. So this should be it right here, but we can actually, as the answer choice says here, we can divide every term by 5 because this is set equal to 0. We can factor out a 5 safely, so we get 5x minus 3y minus 8z plus 9 is equal to 0. So both of these are correct, but this is just a more simplified version. This is probably a better version, and this would be the answer for this question. So again, this is correct. I had to look at this last step here to realize that we can factor out a 5. So this is the correct solution. Great job. And that is the end of number 2, I believe. Yep, number 2. Okay. So, number 3. Which polynomial function could be represented by the graph below? So, unfortunately, there is no graph below. And I'm just going to kind of infer from this response here. So from the graph, we conclude the given parabola. Okay, so this is a parabola with a vertex at 3 minus 3. So that is important. Okay, so it's at 3 minus 3. And we know that x minus 2 and x minus 4 are factors because it has roots at x equals 2. So roots at x equals 2 and 4. So that implies that this function can be broken up into the product of x minus 2 and x minus 4. Because at these values of x, our y is going to be 0. So multiplying these out, we get x squared minus, actually, we can hold off on that for the time being. So the other thing is that we have to make sure that the vertex satisfies this equation. And if it doesn't, we have to add some sort of factor because that's what we know is wrong with our function. So f of x in this case is going to be minus 3, and plugging in for x, we're going to get 3 minus 2 times 3 minus 4, and then we're going to have some sort of constant here, c. And if this is true right here, so if 3 minus 2 times 3 minus 4 is minus 3, then c is just 1. But if it is not true, then we have to set c accordingly so that we don't change the roots, but 3 minus 3 is also a vertex. So we're going to have c times 1 times minus 1. So minus 3 is equal to minus c. And that means that c is not equal to 1. C is actually equal to 3. So really what our equation here should be is f of x is equal to 3 times x minus 2 times x minus 4. So this satisfies the condition for the vertex, and it satisfies the two conditions for a root, because if we were to plug in 2 or 4, we would get f of x being 0. By multiplying this out, let's just get the official quadratic form. So we're going to get 3 times x squared minus 6x plus 8, and then we're just going to get f of x is 3x squared minus 18x plus 24, which is the correct answer as given right here. So I'm going to write that this is the correct solution. Great job. And that concludes number 3. All right. So number 4, we have a triangle PQR and we want to find what the measure of angle P is. So I'm just going to draw this triangle out here, and I'm going to have P, Q, and R. So we have some sort of um, side values here. So the hypotenuse is 57.6. This leg right here is 33.8. We don't know what this leg PQ is, but we can find it if we wanted to using the Pythagorean theorem. This question says find angle P. So this right here is angle P, lowercase p, because it is the angle of big P right here. So the definition of sine theta is the value of opposite side from theta over the hypotenuse. And to elaborate on that, let's assume we have this right triangle, and this is only for the case of a right triangle, and our angle theta is right here. So the side opposite from theta would be this one. So this is the opposite side. The side adjacent to theta that is not the hypotenuse. So the hypotenuse is the longest leg of the right triangle right here. The longest side, rather. And it's made up of two legs right here is what I meant to say. So the hypotenuse is this long side, and it's made up of these two legs, which can either be an opposite side or an adjacent side. So if we're dealing with cosine or if we're dealing with tangent, we have to consider the opposite side and the adjacent side. But because we are dealing with sine, we only have to deal with the opposite side. So because of that, we want to go back to our actual example here, and we want to see what the opposite side of angle P is. So if we do the sine of angle P right here, and we look at what side is opposite of angle P, that would be this side, RQ, just like in this little triangle, and we would see that that value is 33.8. And our hypotenuse is 57.6 up here, and it is this side right here, this longest side that's made up of the two legs holding it, and this would be our denominator. So if we were to evaluate this just by dividing the two values, we would get some sort of decimal. But in order to get angle P by itself, we have to take the sine inverse on both sides. So to get rid of this sine that's attached to this angle P, we have to take the sine inverse, canceling out the sine, and then do the same thing on the other side. So what we're going to get is angle P is equal to the sine inverse of 33.8 over 57.6. And then if we were to evaluate this, so if we were to evaluate this, we would get, if I were to just use just gonna Google this quick. Google is my calculator here, or maybe I should use an actual calculator. That would probably be better. So I don't actually have a calculator on me right now. Oh, here, sine inverse calculator, perfect. So 33.8 divided by 57.6. I'm just going to take this decimal equivalent. Okay, so this decimal equivalent right here, it was angle P is equal to the sine inverse, and it was approximately 0.5868. And if we plug this into any calculator, we get that angle P is approximately equal to 35.93 degrees. And that right there would be our answer. So this answer choice, or this answer given here, was actually correct, but there is a slight mistake here. So I'm going to say the answer is correct, but um, the fraction inside of the sine inverse is flipped. It should be sine inverse of 33.8 divided by 57.6. Good job anyway. And that is the end of number 3. Okay, so number 5 right here. So for number 5, what values of m does the graph of the equation y equals 3x squared plus 7x plus m have 2 x-intercepts? So we're going to have y equals 3x squared plus 7x plus m. And we want to find what is this m value that gives us 2 x-intercepts, or in other words, 2 roots. So what this implies is that if we were to set this equal to 0, as we would do to find what the roots are of any quadratic equation, we can bust out the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, by busting out this formula here, we notice something. So we would, there are certain cases that arise depending on the value of this b squared minus 4ac. So let's assume b squared minus 4ac is equal to 0, right? So what does that mean? If this term is 0, the square root of this term is 0. That means that our root would just be minus b over 2a. So we would only have one root, okay? Similarly, there's another case here. So let's say b squared minus 4ac is any number less than 0. So if it's less than 0, that means that we're taking the square root of a negative number. So it doesn't matter what that number is, it's a negative number, which is, you can't do, it's undetermined, it's imaginary. So we're going to have no real roots. Okay, and we're looking for real x-intercepts here, so real roots. The only other possible case left is that of b squared minus 4ac is greater than 0, right? Because then your roots are going to look like minus b, so we're going to have x equals minus b plus or minus the square root of some number that's not 0, because we already went over this case, over 2a. And this plus or minus here is going to give us 2 roots. And this is precisely the case we're looking for. We're looking for the case of 2 roots. So that means that our assumption is that b squared minus 4ac has to be greater than 0 for us to get 2 roots. So going back to our quadratic equation, we have to define what a, b, and c are. So in this case, a is 3, b is 7, and c is m. So plugging these all into this inequality, we're going to get 7 squared minus 4 times 3m is greater than 0. Or in other words, 49 minus 12m is greater than 0. So this means that 49 has to be greater than 12m, which is the same thing as m having to be less than 49 over 12. So if m is less than 49 over 12, and this solution agrees here, if m is less than 49 over 12, we're going to get the case of 2 roots right here that we want. And that would be our answer, any m that is less than 49 over 12. So that means that this solution is correct. And good job. Okay. So I'm gonna say it's correct. Okay, so moving on to the next question. Which will result in a perfect square trinomial? So a perfect square trinomial is that which can be written. So let's assume two cases of perfect square trinomials. So let's assume this case of ax minus b squared and ax plus b squared. So these are two common cases for a perfect square trinomial. If we were to expand both of these out, we would get a squared x squared minus 2abx plus b squared. And then expanding this out, we would get the same thing, but this minus sign becomes a plus sign. And this is essentially what it has to look like in this form. So this a and b has to exist in order to make it a perfect square trinomial. So if we go through each answer choice, we can expand them out and see if it fits in that same format. So for the first answer choice, we're going to have 3x minus 5 times 3x minus 5. And expanding this out, we get 3 squared x squared minus 2 times 3 times 5x plus 5 squared. So there's a reason why I didn't actually evaluate like 3 squared and 5 squared, for example, because I want to see if this matches the same exact format as any of these examples of perfect square trinomials. So in the case of a equals 3 and b equals 5, we see that this actually lines perfectly up with this ax minus b quantity squared example. A is 3 in here, then 3 and 5 because b is 5, and then plus 5 squared or plus b squared. So we say yes, this answer choice is a perfect square trinomial. Then going on to the second answer choice, we have 3x minus 5 times 5 minus 3x. And let's expand this out again. So actually we can write this in a different way. So we can write this as 3x minus 5, and we can actually factor out a minus sign out of this term here. So like a little hack. So I'm going to put this minus sign on the outside here and get 3x minus 5. And that essentially turns this into a perfect square trinomial as we found in this example. So what we would get is minus 3x squared x squared. Oh, my apologies. It would be 3 squared x squared minus 2 times 3 times 5x plus 5 squared. All right. And this as well would also be considered a perfect square trinomial because it can be refactored back into um, minus 3x minus 5 squared. So because it suffices the same condition that was met in the last part, then yes, this is also a perfect square trinomial. So moving on to the third option, we are going to have 3x minus 5 times 3x plus 5. And right off the bat, this is a case called the product. So when we have so let me first do this product and then I'll explain. So we're going to multiply these out and we're going to get 3 squared x squared minus 2. So no, there's not a minus 2 in this case. So because of these different signs here, we have to consider the sum of the products differently. So we're going to get minus 5 times 3x and then plus 5 times 3x, and then we're going to get minus 5 squared. So first thing to notice is that this term right here, this is the inverse, or sorry, the negative version of this term, so this is just equal to 0. So for that reason, what this really evaluates to is 3 squared x squared minus 5 squared. And this is not of the form of a perfect square trinomial because we are missing the x term. So for that reason, we can rule this out and say no, this is not a perfect square trinomial. And finally, our last answer choice, we can look at 3x minus 5 times minus 3x minus 5, and we're going to use a similar trick to the one that we used for the second answer choice, and we're going to factor out this minus sign here. So we're going to get minus 3x minus 5, and then factoring out this minus sign, we got 3x plus 5. And because this exact product was not a perfect square trinomial the first time around, it is not going to be one again just because of this minus sign. So what this really is minus 3 squared x squared minus 5 squared, right? And for that reason, this is not a perfect square trinomial. And what this is an example of is the difference of perfect squares. So this 9x squared and this, so if we consider this as 9x squared minus 25, this is a classic case of difference of perfect squares. So what this is the product of 3x minus 5 times 3x plus 5. This is a special case, and it's never ever going to be a trinomial. So both of these will not be perfect square trinomials. And that concludes this problem, and this solution is correct. It agrees with every part. And I'm going to say that they did a great job, and that concludes that question. Okay, just making sure I know what number I'm on, and it is number 6. So, number 6, we have to find out the solution of the equation x squared is equal to 19x plus 1. And how we find this solution is, first we want to set it equal to 0, because that's the same thing as solving for the roots of a quadratic equation. So we're going to subtract this 19x and this 1 on the other side, so x squared minus 19x minus 1 is equal to 0. And then the simplest way to solve this is with our quadratic equation. So we're going to do x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, we have to define what our a, b, and c are. So these are just the coefficients in front of our x squared, x, and constant terms respectively. So in this case, our a is 1, our b is negative 19, and our c is negative 1. So substituting all of these values in, we get x is equal to negative 19 plus or minus the square root of negative 19 squared minus 4 times a, which is 1, minus 1, which is c, and then the whole thing over 2 times 1. So simplifying a little bit, negative 19 gives us 19 plus or minus 19 squared is, just to quickly evaluate, 19 squared is 361. And then we do a minus 1 times minus 4 is actually plus 4, so we could do plus 4 over 2. 2 times 1 is 2. And then we can write this, we can just divide out the 2 on both sides, so we get 19 over 2 plus or minus the square root of 365 over 2. And I don't know if this can be simplified further, this square root, but I will just leave it as is. And because we're dealing with this plus or minus here, we can write this as two separate roots. So our first root being 19 over 2 plus root 365 over 2, and our second root being 19 over 2 minus root 365 over 2. And these are our two roots right here. And that is the exact, hold on. Okay, I made a mistake here. Or did I? So x squared minus 19x. So, this person actually made a slight mistake when using the quadratic equation. So they should have plugged in for b minus 19, but they ended up plugging in, they did not plug it in here, and they got instead, it should have been minus 19 and given you 19, so I have to write that out here. So my solution is still correct. When plugging in for quadratic equation, b is equal to minus 19. Therefore, minus b is equal to 19. Hence, the solutions are equals 19. So I'm going to write this as 19 plus square root of 365 over 2 and 19 minus square root of 365 over 2. So I'm going to write that this solution is incorrect. Okay, so number 7. Which quadratic equation is equivalent to x minus 4 squared minus x minus 4 minus 6 is equal to 0? So we have a few answer choices here that we're going to go through systematically. Or in any case, I assume we could just see what is in common. So in all of these answer choices, we see that our substitution that we want to make is u is equal to x minus 4. So let's assume this substitution here, and let's plug it in for x minus 4. So our equation, since this can be written as x minus 4 times x minus 4 minus x minus 4 minus 6 is equal to 0. So I changed this x minus 4 quantity squared into the product of two x minus 4's because that's what a square is. Substituting for u all around the board, we get u squared minus u minus 6 is equal to 0. And out of all the answer choices that we have, answer choice 4 is that. So I would say that answer choice 4 is correct. And the same reasoning is said here. Yes, that would be correct. So this is the correct solution. Great job. All right, and that concludes this question. Okay, so for number 8, we want to derive the equation of the parabola with a focus at minus 5, comma, minus 5, and a directrix of y equals 7. So I already see an issue with the solution. So the solution assumes, I dropped something. So the solution assumes that the focus is at minus 5, comma 5. So that's not the case. So we have to revise the solution a little bit. So of course, the standard form of a parabola when we're dealing with a directrix and a focus is the following. So our h and our k is our vertex, and our p is the distance from the vertex to the directrix. Okay, so how we find the location of our vertex, so how we find the y coordinate, of our vertex is we take the y-coordinate of our focus and we have to add it with the y-coordinate of our directrix and divide by 2. So we take the y-coordinate of the focus, and the y-coordinate of the focus is -5, and the y-coordinate of the directrix is 7. So we're basically finding the midpoint, right? Because if we think about this graphically, if we have a focus -5, -5, and we have a directrix up here, so this is at 7, and this is at -5, our vertex, so this is focus and directrix, our vertex will be somewhere in the middle. And finding this midpoint is simple. You just sum them both, divide by 2, so this is 2 over 2, and we get 1. So the y-coordinate of our vertex is equal to 1. Afterwards, we want to find, we can already find what the x-coordinate of our vertex is. And that's the same thing as the x-coordinate of the focus, because they have to line up, as in this diagram. So the x-coordinate of our vertex is going to be -5. So our h comma k is just going to be -5, comma 1. And now the only thing that's really missing is our p. And what p is p is the distance from the focus to the vertex. And that is just found by taking the y-coordinates, adding them up, and that will give you the, or not adding them up, subtracting them, because the well, if we take the absolute value, right, because we want the actual distance to be positive, so we would take the location of the y location of the focus, which is at -5, and we would subtract it from the y location of the vertex, which is 1. And this would be the same thing as the square as the absolute value of -6, and then we would get 6. So our p is 6. So with this information, we can find the equation rather easily. So rewriting it, we have x minus h squared is equal to 4p times y minus k squared. And our h and our k we found already, so that would be -5 and 1, so we get x plus 5 squared is equal to 4 times 6, which is 24, times y minus 1 squared. And for this reason, this is the correct answer. So because the location of the vertex was incorrect, that means that I will have to point that out. So you assumed that the focus was -5, 5 when it is actually -5, -5 in the problem. Therefore, you get a y vertex is equal to +1. Therefore, the equation is x plus 5 squared is equal to 24, y minus 1 squared. And that would be the correct solution. So this solution is incorrect. Okay, and with that being said, that was the last problem in our problem set. I'd like to thank everyone here for watching. If you, once again, need any more help with homework or any tutoring assistance, please be sure to check out the link in the description. This has been Richard, and have a great rest of your day. Thanks.